Hello everybody and welcome to this tutorial on natural language processing. We're going to have some cool information today, and we're going to cover the foundations of natural language processing so that we can get set up to do more complicated machine learning tasks with language-based processing in the future. Another thing we're going to do in this tutorial, which is really exciting for me, I think I'm going to be an early adopter, is we're going to use the Jupyter Lab. So just a few days ago, Jupyter Lab released an extension to their Jupyter notebooks, which we've been using in all of our previous projects, called Jupyter Lab, which is kind of an improved IDE of Jupyter notebooks. And so I've got this installed, and it's what I'm going to be using today. I encourage you guys to do it as well. We'll see some of the cool features that it provides. Some of the benefits over just standard Jupyter notebooks, or not necessarily benefits but differences. So this is kind of the next step in the Jupyter notebooks line. So installing it's really easy. You can use conda or pip install, just like most things that we've been installing. Conda's been going kind of slow for me in the past few days, so I'm just going to use the pip install. And I actually already installed this, so this is probably going to tell me that I have no updates needed, but that's okay. We'll run it anyways, just for your guys' benefit. So requirement already satisfied, but if you need to do those installs, you can do it here. So one thing that we're going to be doing today is we're going to be using the NLTK toolkit. So this is a natural language processing toolkit in Python. So we also have to do pip install NLTK. This is something that we haven't used in previous projects. And once again, I already have this installed, so we're good to go there. But make sure that you get this and make sure it installs correctly, because otherwise you will not have any of the functions that we're using. Alright, so now just like Jupyter Notebooks, opening up the Jupyter Lab is really simple. All we have to do is type in Jupyter Lab, and if Jupyter is in our path, we can just click enter, and this will start pulling this up. So we'll wait for this for a sec. It takes a little longer depending on the number of kernels you have. I've got a couple because I set up a couple different conda environments. We haven't talked about conda environments much yet. However, they're a good way to kind of control what packages you have installed. So maybe we'll get into that in a future project. Alright, so here comes the Jupyter Lab opening up on the local host. And here we go. I actually have a couple projects in here. The start of our natural language processing. I was building this earlier, but we're going to start a new notebook here. So it comes with this convenient launcher. So this is kind of the difference between just Jupyter Notebooks and the Jupyter Lab here, is that you have your directory over here. So whatever directory you have open, you can see over here. Since I started this in my user's brand tutorial folder, that is what's showing over here. So we've got the previous project we did, which was classifying DNA sequences, and then this one, which is natural language processing. We have a launcher, so we can launch a console. We can also do notebooks, and the benefit of Jupyter Labs is it can display a lot of other things as well: CSV files, text files, and it also has extensions where you could process other data. You've got convenient tabs over here, so you can see which kernels are running or which notebooks are running, cell tools, commands, that type of thing. So really convenient. And I also like this console feature. If you were wanting to do some quick testing, this is just the standard IPython console, but we're not going to use that today. We're going to go into another default notebook. And let's go ahead and rename this. Call it natural language processing. Alright, so we're good to go there. Alright, so like I said, we're going to be using NLTK. So hopefully you already did the pip install NLTK, but just in case, let's go ahead and import this now and make sure this imports correctly. And actually, we can go ahead and do some other imports just to show what we are going to be using, and it did. You see this one here, so NLTK has been installed correctly and it was able to import. So let's do a print. We'll do our standard just to make sure that we are on the same page here. So we have that, and we're also going to do the, let's print out the NLTK version. There we go. And the last one, the sklearn. Alright, let's go ahead and click enter here. So here we go, NLTK 3.2.3, Python 2.7, of course, what we've been using in the past. You can kind of see there's some slightly different formatting here than the previous Jupyter notebooks. You can control all of that in this settings tab, even Jupyter themes. Some people like to have the dark. I like the light personally. I think it's a little bit easier to look at. But whatever you prefer, you can change around up there. Text formatting, that type of thing. Alright, so here we go. So we have the NLTK imported, but we actually don't have everything that we need downloaded. So if we type nltk.download, this is going to open up a sort of download GUI that you shall see momentarily that we can use to kind of install different packages that we're going to need. So here you see it opened up down here, and this is the NLTK downloader. So the green is what you've already installed. So I've already installed some of the popular packages from the collections. All we really need is the popular here. So go ahead and select popular, and then just select download, and that will go ahead. From the corpora, this is kind of like bodies of text. So I haven't installed all of these yet. Some of them it will do automatically when you install the popular, like Shakespeare. It's got a lot of Shakespeare in here. It's the State of the Union addresses. We're actually going to be using those, so go ahead and get those installed, as well as the Universal Declaration of Human Rights. We're going to use that as an example. But you can use any of these that you like. These, like I said, are just big documents of text that we'll be using in this tutorial. Alright, so first let's go over some basics of vocabulary in natural language processing. So I'm going to paste this in here. So another cool thing, oh, here we go. Let's pull this back off to the side. Another cool thing in Jupyter Notebooks that we haven't really talked about is the ability to switch from Markdown to code. So down here, if I switch this to Markdown, we're immediately going to have some different text, and we'll see how this formats in a second. So Markdown text is pretty standard across the Python community, so it's really nice that you can use these cells in here. And so all it's really going to do is it's going to process it as text instead of as a code cell. So that's really handy if you're building a notebook that you want to share with other people, because you can put in well-commented code, as you might have seen in some of the source code examples that you have gotten through EDU Onyx. So here we have some three basic definitions. The corpus, which is a body of text, singular. Corpora is the plural of this. So you saw that in the NLTK downloader a second ago. A lexicon is going to be like the words and their meanings. So for example, the English dictionary. However, other fields are going to have different lexicons. So, you know, when you say something to a hockey player, like let's say you say icing, that's going to mean something way different than if you're talking to a cake maker. And that's just what lexicon means, the words in their specific context. So token here is like an entity that is split up based on certain rules. So for example here, if each word is a token when a sentence is tokenized into words, or you know, a sentence would be a token if you were splitting the sentences apart out of a paragraph. So that's actually what we're going to start with, and it's going to be tokenizing words. So we're going to do that in a sec. In this project, we are actually going to be covering tokenizing, which again is the splitting of the sentences and words from a body of text. We're going to be doing part of speech tagging a little bit later. We'll look at chunking as well as things like stemming. And then this foundation is going to open up the door for machine learning in conjunction with natural language processing. So we're going to be doing a little bit of machine learning in NLP, or natural language processing, and we're going to look at how to tie in the scikit-learn packages with NLTK. And then ultimately we're going to work up to training a classifier with a given data set. But ultimately these are basically just foundational steps. So ultimately we're going to look up to performing live streaming sentiment analysis. And that's going to be pretty cool. So that's what we're building up to. That's going to take us a couple projects. But for now, let's just get started with tokenizing these words. So let's go. We'll have from nltk.tokenize import sent tokenize as well as word tokenize. So in our definition above, we saw that we could split into sentences or words. These are going to do both of those for us. So let's get some example text. Say, hello students, how are you doing today? I've been watching the Olympics. The Olympics are inspiring and Python is awesome. You look great today. Alright, here is our sentence. Just some example text. And let's go ahead and print out the sentence tokenize of this text. Go ahead and click Shift Enter. So as you can see, this is split this into different sentences. We have 3 tokens here. Hello students, how are you doing today? And then we have the next one, the Olympics are inspiring and Python is awesome, as well as you look great today, of course. So let's go ahead and compare that perhaps to the word tokenize of this same text. And if we click Shift Enter here, you see that it's splitting it up into the individual words. Hello students, how are you doing today? As well as you also see that you get the punctuations here. So we have a question mark as its individual token, comma, period, that type of thing. So the word tokenizer will split things up based on the words. Sentence tokenizer, split them into sentence. So this is going to be essentially one of the first pre-processing steps that we are always going to do when we're doing natural language processing. Alright, moving on. So when we're using natural language processing, our goal is to perform some analysis or processing so that a computer can respond to the text appropriately. So the process of converting data to something a computer can understand is referred to as pre-processing, which I just mentioned. One of the major forms of pre-processing is going to be filtering out useless data. So in natural language processing, useless words or data are referred to as stop words. So let's look at removing stop words from NLTK. So we'll add a comment here, removing stop words, which is useless data. So from nltk.corpus, let's go ahead and import the stop words. And so if we ever import something and it tells you that you don't have it installed, you can always go back to this nltk.download and pull up that same GUI and install the packages or the corpus that you need. Alright, so let's print this out. Print set stop words.words, and we'll do this for the English language. Alright, so no module named NLTK corpus. Probably because I typed NTLK. That's not going to work. There we go. Much better. Alright, so here we see all of the stop words in the well, maybe not all of the stop words in the English language, but some words that NLTK has identified as not being that helpful to understanding the entire sentence. So let's look at how we could use these stop words to kind of filter out a sentence. Some of these, just intuitively, you might not think that the word all or perhaps before is useless. However, we'll actually see that from a computer's perspective, they kind of are. So let's get some example. So example here, let's just say this is some sample text showing off the stop words filtration. Alright, so here's our example. Then we're going to do stop words. We got to define these again. Stop words equals set stop words dot words. English is the ones we want here. Alright, there's that. Let's do the word tokens. So we're going to have to tokenize these words. And since we want the individual words, we'll use the word tokenizer. And we'll do this to our example sentence. Then we'll get down to filtered sentence. It's going to equal W. So we're going to do an inline for loop here. So W or word for W in word tokens. So it's going to loop through our word tokens here. If not, W in stop words. So it's going to compare it to the list of stop words, and if it's not in the stop words list or the set, it's going to add it to this filtered sentence here. So another way, or let's just define this in a slightly different way. We're going to show that we could do the same thing with a for loop here. If W not in stop words, filtered sentence dot append W. All right, so this is just two different ways that we can do this. So this would actually do the same thing. Let's go ahead and print the word tokens. Print the filtered sentence as well. And let's actually split this up. Let's do, let's just call this sentence, and so we can actually show that they do the same thing. I just wanted to add an example of an inline for loop here so that we can see those, because this is actually probably better Python programming than using a for loop like this. But at the same time, this is more understandable, it's more readable, so that has its benefits as well. So here we go. So this is some sample text showing off the stop words filtration. That's our sentence above, tokenized. Those are our word tokens. And we've done these two different filtering steps which produce the same results. This sample text, comma, showing stop words filtration, period. So we've removed is. Is actually the only stop word in this, and the, showing off the. So we've removed a couple words here, and we've produced sentences that are both much simpler and don't have this kind of useless data in them. So the benefits of shortening sentences like this is that it's going to substantially speed up our lookup if we're trying to go back and find a similar text. So computationally, it's better to use these filtered sentences. So kind of filtering out these stop words, very common and important first step in pre-processing for natural language processing. All right, now we're going to move on to looking at stemming words with NLTK. So we'll do stemming words with NLTK. All right, stemming is going to be an attempt to normalize sentences, and it is another pre-processing step that we can perform. Excuse me. So in the English language, different variations of words and sentences often have the same meaning. So stemming is a way to account for these variations. Furthermore, it will help us, just like the filtering, the stop word filtering above. It's going to help us shorten the sentences and shorten our lookup. So for example, we could consider two sentences, and the first being, I was taking a ride on my horse. The second being, I was riding my horse. Those both mean the same thing. So if we're able to shorten those down into a similar stem, that is going to be very beneficial for us. So those sentences mean the same thing. They have the same tense. However, that isn't intuitively understood by the computer. So to account for all the variations of words in the English language, we're going to use the Porter stemmer. And this has actually been around for a long time. I believe 1979. But we can import this from the nltk.stem, import Porter stemmer. So it's nicely implemented in NLTK, and it's like most things, really easy to use. We just have to initiate the Porter stemmer here. Let's get some example words. So we'll do a list here. Let's do ride. So we're talking about horses, riding, rider, rides. Alright, so here's our example words, and then we can simply do for W in example words. Sorry, let me scroll down here. We'll print off ps.stem W, where this PS is our Porter stemmer. Alright, so click enter here. And I keep typing NTLK. That's okay. Alright, here we go. So you see here we've split some of these. Rider, it actually doesn't change, and because it actually has a slightly different meaning, but riding, rides, and ride are all just condensed down to the word ride. So this is really useful. We've taken the stem out of these words and kind of removed the conjugations or the tensing, and so this is going to be quicker and easier for us to work with. So now let's take a look at stemming an entire sentence, because it's going to produce some kind of odd results for us. So it's a good idea to look at those. When riders are riding their horses, they often think of how cowboys rode horses. Alright, here we go. Oh, I've got an extra punctuation there. So first things first, word tokenizer. So there's that. And then, just like above, we'll do for W in words. Print ps.stem W. Shift enter. Here we go. So you notice, first things first, it returns all lowercase, so that's helpful. Removes the capitalization. And then, like riders is just stem rider. Some of these don't get changed at all. Riding gets changed to ride. Horses, you actually lose both the E and the S. Still have our comma. Cowboy loses an S. Horses again. Road doesn't get changed to ride. That's still past tense. So here we go. Stemming of an entire sentence. We've kind of condensed these down. So now that we have these stems, we were able to tokenize them, produce these stems. We can move on to part of speech tagging. But we're actually going to get to part of speech tagging in the next video, because otherwise this video would be way too long. So congratulations, you have started building your foundation. We now know how to tokenize words, and we know how to get back the stems. And we're also all set up in Jupyter Labs to continue working with NLTK. So keep listening. This is just the beginning. Thank you very much.